Hello, we are going to be going over section 8.6 today, which has to do with solving rational equations. We've worked a lot on how to multiply and divide rational expressions and how to add and subtract them, finding a common denominator. So today we're going to look at actual equations, equal sign and expressions on both sides, and how do we solve them? How do we find an x value that makes the equation true? So 4 quick steps there on top. Step 1, and this is what we're going to live and die by this chapter, is just always factor. Step 1, factor all the polynomials, especially their denominators, if you can. If it looks like a quadratic, if it looks like we can pull something out, always factor. Step 2, find common denominators. And this is going to be a step kind of from our 8.2 lesson. Figure out what do I need to multiply by each part of the equation to get them all to be a common denominator. Step 3 says once the denominators match, solve the numerator equation. And I'm going to talk a little bit more about that as we get to that step in this first problem. But the basic idea is, look, if both sides of the equal sign are the same, that's what equals means. So if the two sides are the same and the bottoms all match, they all have a common denominator, then the tops had better all match. And so we can solve that equation. We can find our x value. And then step 4, we have to plug it back in to make sure that it doesn't cause an undefined. We've talked about undefined before, undefined meaning causing us to divide by 0 with rational equations. So we just want to plug our final answer back in. So we're going to do a few examples in this video. The first one is on the screen there. 7 over 12 plus 9 over x minus 4 equals 55 over 48. Now, looking at that, first thing is clear, they don't have common denominators, so we can't just solve this straight off. Also pretty clear is the fact that there's no factoring really to be done as far as polynomials go. X minus 4 is linear. We don't have any quadratics. There's nothing we can pull out anywhere. So looking at this, we can use our LCM strategy, our least common multiple strategy from 8.2 to figure out what we should get all these to. But as you do more and more of these, and I think you might actually be at this point already, we can actually just look at this and start massaging the equation to say, okay, how can we get those denominators the same? Here's what I mean by that. For example, I noticed that first rational expression, 7 over 12, if I multiplied it by 4 over 4, and why did I choose 4? Well, that would get me to 28 over 48. 28 over 48. And we have plus 9 over x minus 4 equals 55 over 48. And so I just noticed that, look, I could multiply that first rational expression by 4 over 4, and now it and the rightmost rational expression have common denominators of 48. But we need them all to match. So now I'm thinking, okay, what if I multiplied this by 48 over 48, and then these two by x minus 4 over x minus 4. And if you look at that, before I start simplifying now, that'll give me common denominators. X minus 4 times 48, x minus 4 times 48, 48 times x minus 4. So figuring out, sort of like 8.2, what do I need to multiply each expression by so that we end up with a common denominator for all of them? So I'm going to come down here and I'm actually going to give myself a little more room. I did not leave enough room for this problem. But I'm going to start multiplying. We say 28x and 4 times 28. Oh, turn on the calculator first. 4 times 28 is 112. So minus 112 over 48x minus 4. Plus, I'm going to use the calculator again, 9 times 48, 432, over 48x minus 4. is equal to 55x's minus 4 times 55, 220 over 48 x minus 4. All right, common denominators. And here's kind of that step 3 that I said I was going to come back to. Look, this equal sign tells us that the two sides are equal. And we can quite clearly see that the bottoms are all equal. And so what does that mean for us? Well, if both sides are equal and the bottoms are all equal, that means that the tops, changing color of my highlighter, had also better be equal. I mean, that's the only way around it. We got common denominators. We know the two sides are the same. That tells us that 28x minus 112 plus 432 is equal to 55x minus 220. And that's kind of the key conceptual understanding going from my highlighted step to the one I just drew an arrow to, is saying, look, we've got an equation, we've got the denominators matching. Now we can definitely say the numerators must match as well. Because once we get here, it's an algebra problem. 28x, let's combine those constants on the left, negative 112 plus 432, 320, so plus 320 equals 55x minus 220. I'll subtract 28x's over, that gives me 27x's. I will add 220, that will give me 540, and divide by 27 both sides. It says that x equals 20. So x equals 20. How did we get here? We made sure we worked our equation to get common denominators. Once we had common denominators, we knew we could just solve the numerators. I'm going to highlight that in yellow right here, so it's kind of linked to the numerators above. Once we had common denominators, we just solved the numerators. We get x equals 20. Now that last step, as well as checking our answer, we'll check our answer here. That last step is saying, if I plug 20 back in to my original, will it cause an issue anywhere? Will it cause an undefined issue specifically? Will it make me divide by 0? And we can see the only place we plug it in is right here. So 20 minus 4 is 16. That's not undefined. So I know this isn't going to cause an undefined. Just to check my answer, it doesn't take long. I'm going to plug in the original into my calculator. 7/12 plus 9 over 20 minus 4, that equals that decimal. And if I turn it into a fraction, sure enough, it equals 55/48. So easy way to check, be sure that you got the answer right. X equals 20 on this. Let's try another one. Let's try one with polynomials. 2 over r plus 1 minus 1 over r minus 1 equals negative 2 over r squared minus 1. Step 1, looking at this, I'm hoping that you see, okay, this is a difference of 2 squares. We've seen this many, many, many times. R plus 1, r minus 1. So we've got 3 denominators, r plus 1, r minus 1, and r plus 1, r minus 1. So what am I going to need to do? Well, to get them all to the same denominator, let's just multiply them by their missing parts. So 2 over r plus 1. I'm going to multiply that one by r minus 1 over r minus 1. Now I have r plus 1, r minus 1 on that first rational expression. Minus 1 over r minus 1. And so what's missing there? The r plus 1. So I'll multiply by r plus 1 over r plus 1 equals negative 2 over r plus 1, r minus 1. Nothing's missing there. Take a glance at those denominators and notice they are all the same now. They're all r plus 1, r minus 1. If all the denominators are the same, then we are in business to start solving the numerators. So 2r minus 2 minus, and be careful here because we are subtracting this entire second rational expression. So we need to distribute that negative across all of this. 1r plus 1, it'll eventually be minus 1. Again, if that didn't make sense, we are subtracting the entire second fraction. So minus quantity r plus 1 equals negative 2. 2r minus 2 minus r minus 1 equals negative 2. So 2r minus r is just r. Minus 3 equals negative 2. Add 3 to both sides, r equals 1. R equals 1. Came out nice and clean. Let's make sure it doesn't cause an issue for us if we plug it in. If we plug it in here, we'll get 1 plus 1 on bottom, which is 2. That's fine. We're not dividing by 0. If I plug it in here, we get 1 minus 1. It would cause us to divide by 0. We found a solution, r equals 1, but it's actually an undefined value of this equation. This equation doesn't exist there because if I plug it in actually here or here, the two that I just circled in blue, it would cause me to divide by 0. So this is actually undefined. And so it's not going to be an actual solution. So here we can just say, look, we found an answer, but it turns out it was undefined there. There's no real solution to this problem. So this is just an example of why we have to plug it back in and how this will sometimes happen, where the only solution happens to be undefined. All right, let's try this one. S plus 5 equals 6 over s. Now, I like adding those over 1s because it reminds me, yeah, those are fractions. They're just over 1. So s over 1 plus 5 over 1 equals 6 over s. So I think to get a common denominator, we'll need s over s and s over s. And now we should get s squared over s plus 5s over s equals 6 over s. Common denominators, let's just pick off the numerators and solve that then. S squared plus 5s equals 6. Now let me tell you what a lot of people look at this and say, and you might be one of them, and that's okay. You might say, oh, s is 1. I mean, we plug 1 in, 1 squared plus 5 times 1 is 6. That sure looks like it would work. I'm going to remind you something we saw back in chapter 5, chapter 6, we've kind of talked about. There should be 2 answers here because this was an s squared. It's a quadratic. There are 2 solutions. And so how do we commonly solve quadratics? What do we live and die by this chapter? I'm going to make it equal 0 and then try to factor. S and s, plus and minus, multiply to be negative 6, add to be 5, 6, negative 1, s equals negative 6 or positive 1. Again, going back to that quadratics unit that we had earlier this year. So sure enough, positive 1 does look like one of our answers, but it just so happens there are 2. If you just say that s equals 1, you're only half right. Okay, well we can kind of plug this in, make sure that we don't get 0 anywhere in a denominator. So if I plug negative 6 in, and I'll check it at the same time, we get negative 6 plus 5. Does that equal 6 over negative 6? So step 1, it didn't cause us to divide by 0. And step 2, we can pretty clearly see negative 1 does equal negative 1. Negative 6 is a good answer. What about plugging in 1? We would get 1 plus 5. Does it equal 6 over 1? We didn't divide by 0, so it's looking good. And sure enough, 6 equals 6. So this one had 2 answers. That'll happen. Get a common denominator, solve the numerators, and you'll get however many answers you need, however many you are supposed to get. All right, let's do a problem where we have to translate the English into math. It says the ratio of 16 more than a number to 12 less than that number is 1 to 3. What is that number? So if you remember ratios have to do with dividing. The ratio of 16 more than a number, I'm going to say that that's some number plus 16, 16 more than that number, to 12 less than that number, means I need to start at the number and then go down 12. 12 less than that number. Start at the number, go down 12. Is 1 to 3. The ratio is equals 1 to 3. What is the number? Well, let's solve this in the way that we have been. Get a common denominator. I'm going to multiply this left-hand one by 3 over 3. I'm going to multiply the right-hand one by x minus 12 over x minus 12. At this point, now that we have it set up, we have common denominators. I want you to solve the numerators, check to make sure that we don't get a 0 in our denominator. Check your answer, and then unpause it. I'm going to work it out, and we can discuss it on the flip side. All right, I'm hoping you got x equals negative 30. I've kind of shown my work on the screen there, as well as when I checked it on the calculator. I looked, I said negative 30, plugging that in won't cause us to divide by 0. And I checked it on the calculator, plugged in that left-hand side, got 0.3333, which you probably recognize, and we can use the calculator to turn into a fraction, 1/3. So we can use this mechanism to solve proportions, kind of word problems, anything that has rational expressions on both sides of an equal sign. So hopefully that went well. If not, pause the video right now, look at my work, look at your work, see where it differs, and see if you can find that discrepancy. There's one more concept we need to talk about in this lesson, and it has to do with inequalities. This has been a theme all year through our curriculum, is looking at equations and then looking at inequalities. So solving rational inequalities, not too bad if you've understood what we've gone through so far. Step 1, find any undefined values, anything that makes the denominator equal 0. Step 2, solve the related equation. Pretend it's an equation and just solve it the way we have. Step 3, make a number line, divide that number line into intervals based on any undefineds and any solutions, and then we're going to test in the intervals. So a lot of this should look familiar. We're just kind of recombining some steps. On this problem, 2 over 3y squared plus 6 over y squared, or I totally misspoke there, plus 5 over 6y squared is greater than 3/4, as you see on the screen. Looking at this, where would we get an undefined? Well, anywhere that 3y squared equals 0, so y squared equals 0, so y equals 0, so y equals 0 is undefined. Anywhere 6y squared equals 0, y squared equals 0, so y is 0. If we plug 0 in, it would make both of those denominators equal 0, which would be bad. And we're looking for that greater than 3/4. 4 is never going to equal 0. So I think we're off the hook there. The only undefined value that we really have is y equals 0. Step 1 complete. Just set all the denominators equal to 0, solve for any values. Step 2, solve the related equation. So I'm going to rewrite this as if it were an equation. 2 over 3y squared plus 5 over 6y squared equals 3 over 4. Now, I would love for you to pause this video and think to yourself, what can I multiply each of those by to get a common denominator that we need for this equation? 3, 6, and 4, what can we get them to? How can we make sure they all have y squared on bottom? Pause the video, take a stab at it, unpause it, and then I'm going to kind of talk my way through that, and we'll make sure our thinking aligns. All right, hopefully you paused the video and you've got something down on your paper now. 3, 6, and 4, we could use our least common multiple algorithm, LCM, but 3, 6, 4, pretty small number, I think we can get them all to 12. So I'm going to multiply this left-hand one by 4 over 4, this middle one by 2 over 2, That should get both of those denominators to 12. And, sorry, put the parenthesis in the wrong spot. And this rightmost one by 3 over 3. So now they're all at 12. Well, kind of. I mean, the left-hand one is 12y squared. The middle one is 12y squared. I'd better also multiply by y squared over y squared on the right-hand one. And now if we look, 8 over 12y squareds plus 10 over 12y squareds equals 9y squared over 12y squareds, common denominators. So getting used to, again, just manipulating this equation, multiplying by what we need to get those common denominators. Now that the denominators match, we can just say that 8 plus 10 equals 9y squared. 18 equals 9y squared. Divide by 9 on both sides. 2 equals y squared. Y is going to be the square root of 2. Now, y is going to be the square root of 2. Again, and I know this can be frustrating. When we first learned square roots, we said, oh, plus or minus all the time. Then we got to chapter 7. Chapter 7 was a lot about graphing and radical functions. And so every time we talked about radical functions, we said we can only take the positive version of the solution because it's a function. We want one solution. Here we're not doing radical functions. This didn't have really square roots and domains and range. So I want us to try both plus and minus root 2. And we'll see if they both work in this equation. So I'm going to use my calculator and I'm going to say root 2 store in x and then plug in that whole left-hand side. 2 over 3x squared, because that's what our calculator uses, plus 5 over 6x squared, 0.75 equals 3/4. That's what I was solving for, that kind of related equation. So got that. What if we plug in negative root 2? Let's make sure it works, that we want this plus and minus. It wasn't a function that I'm trying to graph or anything. So let's consider that negative. It also works. So we're going to keep both of those as our answers. Those are, and I should have changed colors if I were on my game. Those are my solutions to the related equation, plus or minus root 2. So step 3 then is right here. I'm going to draw my number line, as I have many times. I'm going to say there's 0, there's root 2, and if you saw in the calculator, it was like 1.4-ish. There's negative root 2, negative 1.4-ish. And I need to test things in each of these intervals. There are a few different places I need to test because 0 was undefined. Crazy things happen at undefined. And then we had 2 solutions, root 2 and negative root 2. I need to test something here, 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 and here. So here's what I'm going to do. I'm going to use my calculator. I'm going to say, okay, these negative root 2's were about 1.41, positive and negative 1.41. So maybe I will test negative 2. That would be on this side. Come to my calculator, negative 2 store x. I'm going to plug it into that equation I already typed out. And if it's greater than 3/4, then we're in good shape. We should include this. 0.375, that is not greater than 3/4, not greater than 0.75. That did not work. Maybe I'll test negative 1, because that'll be in between 0 and negative 1.41. So negative 1 store in x, do the thing that I just typed in. 1.5, is that greater than 3/4, our original inequality? Yeah, absolutely it is. How about positive 1? Positive 1 store in x. And so 1.5 again, so this positive one works. And then let's just try 2. That last interval, even though we have 4 intervals, it's not taking us too long using our technology to work smarter. 0.375, not greater than 3/4, does not work. So what is my final answer? It was just greater than, so I know there's an open dot here. There's an open dot here because it was undefined, and an open dot because it was just greater than. I'm going to say that my answer then is -√2 to 0, with parentheses, not including either of those, unioned with, combined with, that's what that U means. It's kind of like an and, if you can think of it that way, and 0 to √2. So those are the 2 intervals on my number line that worked. Why could we not just go straight from -2 to -√2 to +√2? Because 0 does not work. 0 causes an undefined. We found that in step 1. That's why we needed that step 1. So just rehashing this strategy, find any undefined values, find your solution, put it on a number line, test intervals, and write out your final answer. So inequalities, that's a little bit more work, but again, the big step is step 2, which is solving it as if it were an equation, hopefully familiar, similar to what we've been doing earlier in this video. But guys, that is 8.6, solving rational equations, solving rational inequalities. Take a look at your practice problems, bring any questions you have to the table when we next meet, or just reach out directly if you want to get those questions answered a little bit sooner. But really do practice these skills. Solving equations, if you think back to Algebra 1, was kind of a big deal. Solve 1-step equations, solve 2-step equations. Now in Algebra 2, we're going through and saying, okay, solve radical equations, solve rational equations, these kind of special, more advanced types. But they're still as fundamental, and you need to be able to do them moving forward. So take a look at these problems. Let me know if you have questions, and I will see you in the next video.